Transmission lines 1. So what is transmission line? Transmission line is defined as path of carrying information in the form of electromagnetic wave from source to destination. So mainly transmission lines are useful to send information from one point to another point. So these are some examples for transmission lines, coaxial transmission line. So we have different types of transmission lines: parallel wire transmission line, coaxial transmission line, waveguides, optical fiber, microstrip lines. So parallel wire transmission line, so these are combination of two parallel conductors. So we have different parallel wire transmission lines. One is low frequency high power line, another one is high frequency low power line. So these are parallel wire transmission line. Coaxial transmission lines. So here in this coaxial transmission line, so here two conductors are arranged coaxially. So an advantage of coaxial transmission line: outside conductor providing electromagnetic shielding, so there is no leakage of electromagnetic wave propagation into the free space. So there is no leakage of information from transmission line. It is advantage of coaxial transmission line. So there is a difference between transmission line and antenna. So transmission line must be lossless. Antenna is one lossy transmission line. So here waveguides. So waveguides also an example for transmission line. So mainly waveguides are useful for microwave transmission line. So waveguides are hollow metallic structures. So these are different waveguides: parallel plane waveguide, rectangular waveguide, circular waveguide. So waveguides. So with multiple reflection, there is propagation of wave within waveguide. Optical fiber. Optical fibers are working on the principle of total internal reflection. Optical fibers having some advantages over other transmission lines, mainly superior transmission quality, higher information carrying capacity due to tremendous bandwidth, lightweight and smaller size, reduced cost and higher security. Microstrip lines. So these are different transmission lines. These lines are particularly important in integrated circuits where metallic strips connecting electronic elements are deposited on dielectric substrates. Microstrips are used in circuit components such as filters, couplers, resonators, antennas. These lines having greater flexibility. So main advantage of microstrip lines: size of microstrip line very small. Also it is very easy to fabricate compared with other transmission lines. So it is comparison of transmission lines and waveguides. So here loss point of view: waveguide offering very low loss, microstrip line offering very high loss. So microstrip lines are open strip lines, so there is more radiation. That means there is leakage of signal into the free space in case of microstrip line. Power handling capacity of waveguide is very high compared with other microstrip line and coaxial line. So in case of microstrip line, fabrication is very easy, physical size very small. Also integration with other components. If respect to microstrip line is very easy. Now coming to transmission line parameters. So it is equivalent model of transmission line. So here resistance, inductance, capacitance, conductance, these are primary constants of transmission line. So coming to transmission line equations, so by taking the equivalent model of transmission line, here I'm going to derive transmission line equations. So here by applying KVL and KCL, finally, so these are the transmission line equations. D square by dz square v minus gamma square v equal to 0. D square by dz square I minus gamma square I equal to 0. So here gamma is propagation constant. So gamma, it is a combination of primary constants of transmission line R and GC. So by applying KCL and KVL, here we got these two transmission line equations. One is voltage equation, another one is current equation. So coming to propagation constant, it is a secondary constant of transmission line. The function of primary constants of transmission line R and GC. So gamma is combination of real part alpha and imaginary part beta. Alpha is attenuation constant, beta is phase constant. So alpha represents measure of attenuation of EM wave, beta represents measure of phase variation per unit wavelength. So propagation constant. So here alpha beta equations from gamma. Coming to characteristic impedance. So characteristic impedance of transmission line, it is a ratio of positively traveling wave to current wave at any point on the line. So now, so coming to characteristic impedance equation, that is square root of R plus j omega L by G plus j omega C. So it is a characteristic impedance of transmission line. So we have different transmission lines. So here first one is lossless line. So lossless line means the transmission line is said to be lossless if the conductors of the line are perfect and dielectric medium separating them is lossless. So condition is R equal to G equal to 0. So these are characteristics of wave propagation in the lossless line. So the lossless line attenuation alpha equal to 0, beta that is equal to omega square root of LC. That means beta is directly proportional to frequency. Z0 is purely real. So velocity of wave propagation is 1 by square root of LC. So these are the final conclusions. Propagation constant is purely imaginary. Characteristic impedance is purely real. Phase constant linearly dependent on frequency. Distortion line, distortionless line. So distortionless line is one in which attenuation constant alpha is frequency independent, while phase constant beta is linearly dependent on frequency. So condition for distortionless line is R by L equal to G by C. So these are the characteristics of wave propagation on distortionless line. So here final conclusions. Attenuation does not dependent on frequency and it is constant. So here see the equations. Alpha, that is square root of Rg. Alpha is not depending on frequency, it is constant. Phase constant is linearly dependent on frequency. Phase velocity is independent on frequency. V equal to, that means velocity V equal to 1 by square root of Lc. So lossless line is desirable in power transmission, telephone lines, and that means lossless lines are desirable in power transmission. Telephone lines are required to be in distortionless line. Low loss line. So coming to low loss line, condition is R very less than omega L, G very less than omega C. So these are the equations for low loss line.